So, now looking at Chapter 2, Section 3, we're looking at Newton's second law of motion. Well, Newton's first law of motion was Galileo's laws. Is three laws of motion. The law of inertia. An object has a tendency to stay at rest. An object has a tendency to stay in motion. And a force needs to be acted upon an object in order to change its motion. Newton's second law is how that force affects the change on an object. Now, first of all, let's define what a force is. Force is nothing more than when you experience a push or a pull. So if you're in a situation where you feel a pull, you're feeling a force. And a perfect example of that is weight. When you are weighted, if you're heavy, like we all are because we're all in a gravitational field, you'll feel the pull of gravity. If I jump up, I feel gravity pulling me back down to the earth. If gravity wasn't there, I jump up and I continue to move upwards. Okay? But the pull of gravity pulls me down. The force of gravity pulls me down. The weight of gravity pulls me down. So when we refer to weight, we're referring to a force. Cool? Alright, so what is force? Well, push or pull. What are the units of force? Well, because Newton is really the man that comes up with the idea of force, we think of the unit of force as a newton. So if I were to push you, I'm pushing you with so many newtons. My weight is in the SI standards and international standards is expressed in newtons. I weigh so many newtons. Okay, and the abbreviation of this is the capital N. Capital N because it's a unit after somebody's name, a newton. Okay, so the unit of force is a newton, expressed with a capital N. Cool? Now how much is a newton? Well, if you think about it, an object as light as an apple is approximately between 1 and 3 newtons, depending on the weight of the apple. Your remote control, your TV remote, is about 1 newton. You know, it's just that much weight that you're feeling in that object is about 1 newton. So it's not a big value. So to experience something like 100 newtons is not. It's like carrying a bag full of 100 apples. Now, probably more like 50 apples, but nevertheless, you're looking at that many apples. I mean, it's significant, but it's not that much. Okay? So that'll give you an idea of what a newton is. Now back to Newton's second law, because here we are just describing what a force is. Newton's second law says that if forces are acting on an object, that object can experience an acceleration, depending on whether the forces are balanced or unbalanced. Well, balanced and unbalanced. Looking at myself, I'm not accelerating. I'm going to stand right here and I'm not accelerating. So if I look at myself, I can examine all the forces that are acting on me. Well, I weigh. And of course I weigh a little bit too much. I have the force of gravity pulling me down. And that's the equation for the force of gravity, mg. Then I have another force, and it has several names. The first name it's called is normal. It's also referred to as a reactionary force. In that I'm standing on the ground and the ground is pushing me back up. The ground is preventing me from being pulled down any further than what I'm at right now. So gravity is pulling me down. It's pulling me down to the floor. The normal force is pushing me back up. Okay? So it's a balanced system. The normal force balances out with the weight of that object. Okay? It responds. So it's balanced. Now, if I didn't have a floor below me and I decided to just like parachute out of a plane, what I end up having is an unbalanced force. So here's my body again, and now I'm jumped out of a plane. Well, there's still weight pulling me down. As long as I'm always on the surface of the Earth, or at least in another, massive object like the Earth or the Moon or the Sun or whatever. Don't go jumping off the Sun. there's always going to be that weight. So when I leap out of that plane, I'm being pulled down by the force of gravity. And without a normal force on the ground to push me back up, I'm going to start falling down. And I'm going to fall faster, 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 faster. I mean, in an atmosphere, we do experience something called air drag, and that eventually gets us to a terminal velocity. But in some place like the moon, where there's no real atmosphere, you simply just fall faster and faster and faster. Okay? Mercury being another example. There's really no atmosphere on Mercury. You drop and you go faster, 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 faster until you hit the surface. Okay? So, this is an example of an unbalanced force. So, what we know is a balanced force produces no acceleration. An unbalanced force does produce an acceleration. Okay? Cool? So that's the basics of Newton.